Hello everyone, and welcome to How-FixIT. If you've spilled a sugary drink like cola, juice, or an energy drink on your controller, and the buttons are now sticking, don't worry, I'm here to help. In this video, I'll show you how to completely disassemble the 8BitDo Ultimate Bluetooth controller, properly clean the circuit board, replace faulty parts, and restore the controller to full working order. The reassembly process is included in this guide, so you will easily complete the repair. Before we start, here's what you'll need. Precision screwdriver set with Torx T6 and Phillips No. 1 bits. Plastic opening tools and a pair of tweezers will be useful during the disassembly process. Cotton swabs and isopropyl alcohol, 91% or higher, for proper, safe cleaning. I've included links to all tools and replacement parts in the video description below. For best results, I highly recommend using a magnetic mat. Controllers have many tiny screws of slightly different lengths, and keeping them organized is essential for smooth reassembly. A magnetic mat lets you part each screw in its own spot and prevents mix-ups. A simple tool that makes a big difference. Alright, let's get started. On the back of the controller, remove the two covers. Using a Torx T6 screwdriver, remove 3 screws on each side. If your bit is too short to reach one of the screws, grip the bit with pliers and twist a couple of turns. Once it loosens, remove it with your fingers. Use a plastic opening tool to start prying the shell from the bottom edge. Take your time. A ribbon cable still connects the two halves. Open the connector and disconnect the ribbon cable. Now the controller is open in two parts. The top half holds the board with the face buttons, the bottom half holds the logic board, battery, vibration motors, and triggers. We'll start with the top half, since it's the most vulnerable to liquid. Remove the 7 Phillips screws securing the board to the top shell. Now we've reached the button mechanism. Here's how the button mechanism works. On the green circuit board, each button has a circular graphite contact. When you press a button, the graphite pad on the silicone membrane touches the circuit board contact and completes the circuit. If sugary liquid gets on the silicone membrane, buttons stick. If it reaches the graphite contacts, presses may not register. To restore function, gently wipe the graphite contacts on the circuit board with isopropyl alcohol. Clean the black pads lightly. Do not scrub, as the graphite layer is delicate. Isopropyl alcohol is safe for the circuit board, but not for the silicone membrane. We'll clean those differently. Now that the board contacts are clean, let's move on to the silicone membrane. If sugary liquid affects the silicone membranes, their elasticity suffers and buttons begin to stick. Do not clean silicone rubber seals with alcohol, as it leaches plasticizers that keep the material flexible, leading to stiffness and reduced sensitivity. The best way to clean silicone membranes is warm water with a drop of liquid soap or dish soap. Rinse thoroughly, apply a little soap, gently scrub, then rinse until all soap is gone. Dry completely. Trapped moisture can cause corrosion. This removes sugar and stickiness safely. Avoid acetone, solvents, gasoline, kerosene, or scented alcohols. They seriously damage silicone. If a contact looks matte or gray after a spill, the conductive layer may be damaged by sugar acids or simply worn from heavy use. In that case, replace the rubber pads. You'll find a link in the description below the video. Remove all face buttons from the front panel. You can wash the buttons in the front shell with soap and water. Dry them completely before reassembly. We are done with the front panel. Now move to the back half of the controller. Remove the analog stick caps by pulling them up. If the analog stick caps are worn, you can replace them with new ones. Remove the 3 screws securing the circuit board to the back shell, then lift the board out. Remove the small switch. Disconnect the vibration motor table and lift the motor out. Remove the 2 screws securing the circuit board to the plastic plate and the battery cover. With the battery cover removed, you'll see the battery is soldered to the logic board. Replacing it requires a soldering iron and experience. If your controller won't charge, the battery may be deeply discharged and the board is blocking operation. You can replace it with any compatible lithium polymer battery of the same dimensions. After the battery controller should work again. Remove the L2 and R2 trigger buttons and be careful with the small springs. They're essential for proper function. We'll reinstall them later. Release the plastic tabs at the top and bottom to remove the logic board from the backing plate. Flip the board and disconnect the ribbon cable. A quick note about the logic board: replacing the analog sticks requires soldering. Both sticks are soldered to the circuit board. A broken USB-C port also requires soldering. The rear P1 and P2 buttons are mechanical switches soldered to the board, no silicone membranes. In short, replacing the sticks, USB-C port, battery, or rear buttons requires a soldering iron and proper technique. Now remove the L1 and R1 trigger buttons. These triggers use silicone membranes and a flex cable with graphite contacts. If L1, L2, R1, or R2 are sticking or unresponsive, clean the contacts the same way as the face buttons. Also, clean the contacts where the trigger flex cable connects to the logic board. If cleaning doesn't fix the issue, replace the trigger's silicone membrane or the flex cable. That almost always restores function. Return to the back cover and remove the P1 and P2 buttons along with the contact pad for the charging dock. That's everything on the back cover. At this point, the controller is fully disassembled. You now know how to clean sticky buttons, restore button functionality when the mechanism is worn, and replace any faulty parts. Before reassembly, take a short break to reset your focus, then reassemble carefully in reverse order. Before reassembling the controller, make sure that every component is completely dry. Even a tiny amount of moisture can cause corrosion, ghost inputs, or buttons that randomly stop working over time. Once everything is dry, begin by placing all the plastic buttons and silicone membranes back. Check that trigger springs and side buttons haven't shifted. Make sure each button sits freely in its slot without friction, and verify that the orientation is correct, especially for the D-pad and face buttons. These rubber pads must sit perfectly flat on the board and align with the mounting pegs. If a membrane is flipped or slightly offset, the button may not register when pressed. After that, gently position the logic board back into the shell. Do not push it down by force. If it doesn't sit correctly, something underneath is misaligned. Before closing the controller completely, press all buttons several times. They should bounce back smoothly without resistance. Reinstall the external screws, again tightening them evenly. Once the controller is fully assembled, perform a final functional test. Press each button, test the D-pad in all directions, squeeze the triggers, and move both analog sticks. Ideally, test the controller in a device or input viewer to confirm that every input is detected correctly. I included a link to this test page in the video description below. If any button feels stiff or doesn't register, slightly loosen the screw nearest to it by a quarter turn. In most cases, this removes unwanted pressure from the circuit board. After everything tests correctly, the controller is ready to use. If this guide helped you repair your controller, feel free to like the video and subscribe to the channel for more repair tutorials and troubleshooting tips. Thanks for watching How-FixIT, and we'll see you in the next one.